Okay, so here is the first one for your homework, cotangent. The period is indeed pi. Cotangent and tangent have a period of pi over b. The other four, it's 2 pi over b, but cotangent and tangent, it's just pi over b. Here, b is 1, so the period is just pi, which makes a quarter of a period, pi over 4. There's a phase shift to the right, pi over 2. And maybe it's not so clear right now what the asymptotes are. Maybe they are. The cotangent naturally has a vertical asymptote at x equals 0. That's what cotangent, the parent function, would have at x equals 0, a vertical asymptote. So knowing that, and then knowing that everything went to the right, pi over 2, you know that you have a vertical asymptote at pi over 2, at x equals pi over 2. So how do you get this? Well, the vertical asymptotes occur at every period. So if you know where 1 is, all you have to do is add or subtract any multiple of the period to get the next one, which is why this n times pi is there. Vertical shift, there is none. And that is enough information to graph it. You would start by graphing the midline, which in this case is 0, graph a couple of vertical asymptotes. You would always put a dot right in the middle. It's centered. And then the vertical stretch is 3, vertical stretch of 3. So normally a quarter of the way through the period, you would only go up 1, because that indicates like that. Going back to the unit circle, that's like the cotangent of pi over 4. But here, the cotangent would still produce 1, but that 1 gets multiplied by 3. Everything gets tripled. So that 1 becomes a 3. What would normally be -1 becomes -3. So that's how you indicate the vertical stretch. And that's how you can get these ordered pairs. The second one is secant. You absolutely would graph the cosine version first. And it says draw the reciprocal function. So Mariana de Grey here, she rewrote it as a cosine function, but then also factored out the b value. Here the b value is a half, which makes your period twice as long, because the period for secant is normally 2 pi, but if b is a half, then it becomes 4 pi. That's just 2 pi divided by b. And when you factor out a half, 3 pi over 4 becomes 3 pi over 2. So this tells us that we actually went to the right 3 pi over 2, right there, phase shift. So when you start graphing, you would start at 3 pi over 2 to the right. So if a period is 4 pi, that means a quarter of a period is just pi. So starting at 3 pi over 2 to the right, you would just add a full pi to get all these key points. And that's exactly what, without even looking at the graph, these x values are correct, because 3 pi over 2 is where we would start. And then if I add a quarter of a period, that's pi. So that's 2 pi over 2. That gets you to 5 pi over 2. And another 2 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. And let's see here. This is cosine. So cosine starts at the top of the hill, which is, this is just really nice job. It's really clean. It's much cleaner than I can do it. So you start at 3 pi over 2 to the right, and you're up at the top, which is where cosine naturally starts. You go all the way down, keeping in mind that your midline is -2. Your amplitude is 3. So you're spanning from -2 up to 1, and then down to -5. So you just put in a dashed line for cosine. You draw your vertical asymptotes every time that cosine function hits the midline. And that's the hard part. I mean, everything, that seems like a lot, I know, but once you get there, actually graphing secant is the easiest thing in the world. It has to touch the maximums and the minimums, and you use the asymptotes to guide it. These should be a little bit more bended. I'm not sure if that's the right word, but they should be a little flatter at the bottom. So I drew mine a little too flat, but not so much of a sharp angle right here.